Hey everyone, let's talk about the sun. You see it every day, right? But what if I told you that according to the old rules of physics, it shouldn't be on at all? Seriously. So today, we're diving into a full-on quantum detective story to figure out how our sun even exists. So let's just get right to it. Here is the paradox at the heart of everything. You take the classical physics that we use for hundreds of years, you point it at the sun, and the math says it should be a cold, dark ball of gas. So what's going on? What's the secret? All right, to crack this case, we first have to understand just how big the problem is. We're not just talking about a fire. We're talking about an impossible fire, lighting up our solar system. And this really shows you the disconnect. We see a blazing star with a core temperature of 15 million Kelvin. But, and you're not going to believe this, by the old rules, that is way too cold for nuclear fusion. The tiny protons in the sun's core just don't have enough juice to slam together and fuse. So the sun we see and the sun classical physics predicted are two totally different objects. So what's holding these protons back? Well, it's time to meet the main villain of our story, a fundamental force of nature. It's called the Coulomb barrier. You know how if you try to push two positive ends of a magnet together, they fight you? It's exactly like that, but on a cosmic scale. Protons are positively charged, and they repel each other with this incredible electrostatic force. It's like an invisible but super powerful energy wall between them. And here's how that plays out. You've got two protons zooming toward each other. They get closer, closer, and then bam, that Coulomb barrier kicks in. It's this energy force field that just screams, not happening, and shoves them apart long before they can get close enough to fuse. And according to the old physics, this should be the end of the story, every single time. But you guessed it, that is not the end of the story. Because when you zoom all the way down to the tiniest scales imaginable, the universe has a secret set of rules, a loophole. And this is where we enter the quantum realm. Down here, with protons and electrons, reality gets, well, it gets really, really weird. All the predictable, solid rules of our big world, they just don't apply anymore. Things start acting in ways that feel a lot like magic. And here is the absolute game changer. In the quantum world, a particle isn't some tiny solid ball. It's also a wave of probability. It's kind of smeared out. It doesn't have one single location. It has a chance of being in a whole bunch of places at once. And that little fact changes absolutely everything. So, how does all this quantum weirdness actually help our protons? Well, it gives them an escape hatch, a way to literally cheat that impossible barrier we were just talking about. Okay, to make sense of this, think of it like this. That Coulomb barrier is a giant hill, and our proton is a little ball trying to get to the other side. Now, in our world, if you don't give that ball enough of a push, what happens? It rolls partway up the hill, and then it rolls right back down to you. It fails. It never makes it over because it just doesn't have the energy. That's the classical physics version. But remember, our proton isn't just a ball. It's a wave of possibility. And a tiny piece of that wave actually leaks through the hill. This means there is a very, very small, but not zero, chance that the proton just doesn't even bother trying to go over the hill. It just uses the laws of probability to, poof, appear on the other side. This mind-bending trick is called quantum tunneling. The proton doesn't smash the wall down. It doesn't find a hidden door. It pulls off a quantum magic trick and just shows up where it needs to be. It tunnels right through a barrier that it should never, ever have been able to cross. And this isn't just some weird physics trivia. This quantum cheat code is the very reason the sun shines. It's the reason we have light and warmth and life on Earth. So once a proton tunnels through that repulsive barrier and gets right up next to another one, a whole new force takes over. It's called the strong nuclear force. It is unbelievably powerful, but it only works at incredibly short distances. And it just grabs those two protons, smashes them together, and locks them in place. And just like that, fusion begins. This is the very first step of something called the proton-proton chain. When those two protons fuse, they actually change, forming a new particle called deuterium. And in that one tiny moment, a little bit of their mass vanishes and is converted into a pure burst of energy. And where does all that energy come from? Well, you know this one. Einstein's E equals mc squared. Energy equals mass times the speed of light squared. The new particle that's created has just a tiny bit less mass than the two original protons did. And that missing mass is what became the raw energy, the sunlight that powers our entire world. Okay, but you might be thinking, hold on, if this tunneling thing is so rare, how does it power the entire sun? And that is the perfect question. The secret is all about scale. The chance of any single proton doing this is, ridiculously low. But the number of protons in the sun is just astronomical. We're talking trillions upon trillions. So you're taking an event that's almost impossible, and you're giving it trillions of chances to happen every single second. The result? A continuous, massive, roaring furnace. So just think about that for a second. The sunlight that's hitting your face right now, the energy that grows our food, it's all powered by a quantum cheat. It is the result of countless tiny impossibilities all happening at once. Our star is basically a giant monument to the weird power of probability. And that just leaves us with this one last incredible thought. We just found out that the most ordinary thing in our sky, the sun, works because of a principle that completely breaks our common sense. It really makes you wonder, doesn't it? What other parts of our reality, things we see every day, are secretly being run by the strange, beautiful, and impossible rules of the quantum world?